I was thinking about you guys because I was reading, I think it was just in the Press Enterprise, in the paper, they were talking about alternatives for graduations. And one school is doing a graduation at a drive-in and
I heard about that.
Putting the kid's picture and name on the screen, and everybody would sit in their own cars, and broadcast it hear it over their radio. But the University of Pennsylvania, Penn down in Philly, some of the students created the campus using Minecraft.
We need to do that for ours.
They want to do a virtual graduation using Minecraft because they've done like the whole campus via they're not done yet. There's a whole bunch of these geniuses working on it. Like they're just like really smart and they can't go to class. So I think they're doing all their schoolwork online, just like you guys. But in their free time, they're recreating everything via Minecraft. So
Aristotle, we should recreate the school on the server.
Yes.
Oh gosh.
I'll help you guys.
If you can connect, Brian.
I know. I'll try my hardest.
Hey Brian, speaking of connecting, you didn't do your Sumdog challenge.
Yeah, I couldn't find my password until today.
I extended it for today, just so you can. I extended it for today just so you can get it done.
Okay.
All right, but you have to do it today.
Mm-hmm.
But other than that, I think you guys all got that in. So good job.
Where is everyone? We're missing Luke and Lily.
Luke hasn't been on any of
No,
the
I
things.
don't-
I'm assuming he
Yeah.
lost his internet again.
Well, Lily, she was at religion, but she wasn't.
Well, she'll probably just take a little bit to join.
Yeah, maybe their internet isn't working.
Okay. Well, we'll just get started. We're just missing the two, right? We're going to start with homework. So we won't get into the new stuff just yet, but we will later today. Let's go over what you had to do, though, on page 591. So last week we talked about special triangles. We did the 45, 45, 90. And right before we left for Easter break, we were working on the 30, 60, 90. So these should be problems on 30, 60, 90. Okay. 18 to 25 on page 591. Okay, I'm just going to give you the answers, and then you can let me know if you don't understand why it's that, and we can go over it. But we do have some new material to cover, so I'm going to go over these, check your work, and then let me know if we need to go over any of them. Okay, 18 to 25. 18, x equals 8, y equals 16. 19, x equals 10, y equals 20. 20, x equals 15 root 3 over 2, y equals 15 over 2. Right, 21, x equals 17 root 3 over 2, y equals 17 over 2. 22, x equals 24 root 3. Y equals 48. 23, x equals 14 root 3 over 3. Y equals 28 root 3 over 3. Questions on any of those first 6 triangles? No. Okay. 24, determine the length of a side of a triangle. Okay, this is an equilateral triangle. Length of a side, 12 root 3, or about 20.8 feet. Any questions on that one? Okay. 25, 16 root 3, which is about 27.7 feet. Anything?
No.
All right. Okay, then we did 28 to 33. Okay, 28. X equals 13 root 2 over 2. Y equals 45. $29. X equals 3 root 2. Y equals 6 root 2. $30. X equals 3. Y equals 1. $31. X is 5. Y is 10. $32. X is 6 root 3. Y is 3. And 33. X equals 45. Y 45 degrees. Y equals 12 root 2.
Mrs. Palmer, how do you get number 30?
All right,
Wow.
let's take a look at number 30. Okay, I'm going to draw the triangle first. All right, so with these, they were kind of giving us a couple of triangles. So we have an altitude down, and also this is a right angle. Okay, so we have a 30, 60, 90 triangle. We know that the side opposite, if we're looking at the big triangle, and even the smaller triangle, we know the side is 2 root 3. Okay, so we're looking for short side of both the smaller triangle and on the hypotenuse of the larger triangle.
Okay.
So let's look at the smaller triangle first. All right, so basically you're cutting off that part. Okay. So you have, if you look at the smaller triangle, the one on the left, that makes this angle up at the top 60.
Okay.
All right, so you have a 30, 60, 90. We're cutting off this end of it.
Okay.
And we're looking at a 30, 60, 90. All right, across from the 90, we have 2 root 3. So that's the hypotenuse of that smaller triangle. And we're looking for X, which would be our large side. Okay, our long leg. Okay, and so it says for 30, our long leg is, does it give us that? Our long leg is 3. And okay. All right, so 30, 60, 90. What do we know? If we have the hypotenuse, how do we find the long leg? What's the rule for 30, 60, 90s? What are our...
The length is the side and square root of 3.
Okay, the short leg root 3, and the hypotenuse is 2 times the short leg, right? Okay, so if the hypotenuse is 2 root 3, we know the short leg then is root 3. All right, so I'm going to put the short leg in there, root 3. Okay, the long leg is the short leg times root 3, right?
Yep.
Okay, so we're looking for X, which is the long leg. So it's going to equal our short leg, which is root 3 times root 3.
Okay.
Right, so X is root 3 times root 3, which is 3.
Okay.
Okay, so that's how we got X. All right, so X is 3. So now we're looking at the whole bigger triangle. I'm trying to think if I want to do it. I do think I want to do it that way. Yeah, so look at the whole bigger triangle, okay?
Yeah.
So this time we have a 30, 60, 90, but like XY is our hypotenuse.
Okay.
And we have the long leg, which is 2 root 3. So that's going to make the short leg root 3. Okay, so that's the short leg over here.
Okay.
All right, so that's root 3. So our whole hypotenuse, how do you find your hypotenuse?
2 times the short side.
Okay. 2 times the short side. I'm trying to think. our y is 1, so we want our hypotenuse to be 4. I'm going to think about, I must make sure I'm doing that one right. 2 root 3. That's not it. Our short leg is 2 because we have our long leg, which is 2 root 3. Sorry. Short leg's 2, right? Because long leg is short leg times root 3. So our short leg is 2. Our hypotenuse is 4 then, right? Because the hypotenuse is twice the short leg. And you know that x is 3. And we need the whole thing to be 4. So y is going to equal 1.
Okay. Thank you.
You're welcome. All right. Any other ones you guys want to look at?
How about 31?
31. Okay, so we start with this giant rectangle. All right, and then, so these ones were a little bit trickier because there's just like multiple triangles in here. So let me draw it up. Okay. And we're looking for x and we're looking for y. And it gives us 5 root 2, which I'm assuming is that little piece in there. They kind of write it in a weird spot where it's almost near the x, but since it wants us to find x, I'm thinking that the 5 root 2 is that piece coming up from the middle to the corner. Okay. Okay, since this triangle that we're making right here, Brian, this one, it says these legs are congruent. That makes it and this is 90 degrees here. It's making it a 45, 45, 90, just because those legs are congruent, okay? So that means, and we know that the end is a 90 degree, so it's basically breaking that in half into 45 and 45. So this smaller triangle here where my x is, that's also a 45, 45, 90. Okay, so I've got the hypotenuse of this triangle, which is 5 root 2. And I want to find the leg, so I just have to divide by root 2. All right, so 5 root 2 divided by root 2 would be 5. So that's how that x is 5. All right, then they want us to find y. All right, y is up top here. It's the hypotenuse of these. Okay, so this is your leg is 5 root 2. We're going to multiply that by root 2 to get our hypotenuse, or to get y. So 5 root 2 times root 2 would be the same thing as 5 times 2, which would be 10. Okay? Because y equals 5 root 2 times root 2. And that's where that 10 came from. Do you still need to see it, Brian?
Okay, fine.
Okay. Okay. All right. Our next section is called trigonometry.
No.
All right. I'm getting ready to start some trigonometry. You're going to be introduced to the term sine, cosine, and tangent. Okay, these are trig functions. This is the crux of what you need to know is this.
Yeah.
SOH-CAH-TOA. So if we were in the classroom, I would have this hanging now for you. That's everything you need to know for this. Right here in this little mnemonic device. SOH-CAH-TOA. Right. So if you go up to some older friend of yours who took geometry or trig several years ago, okay, if you ask like an older sibling who has done this, or mom or dad, and you say SOH-CAH-TOA, they're going to go, oh, sounds familiar, but, you know, it's kind of hard to remember that after 5, 10, 20 years. But then when you start talking about it, they'll be like, oh, yeah, I remember now. Okay. This has to do with triangles. And just write this down somewhere in your notes, okay? That means sine is opposite side over hypotenuse. So that's what the SOH is for. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. All right, so that's the CAH. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. All right, so if you talk to mom and dad today, Morgan, if you talk to, or Grace, if you talk to Morgan or Sam, though, if you say SOH-CAH-TOA, they're going to go, wait a minute, it sounds familiar. And then they'll be like, oh, yeah. All right. That's how you guys will be like 5 years from now. Oh, yeah, I remember that. Okay. Opposite over adjacent for tangent. Okay, this is all on page 596 in your book, but these are the notes you should have down for it. Okay. I kind of like the beginning of this chapter because it reminded me of Father Lease, which also makes me want to tell you this story. A friend of mine's son is a priest, and he is young. He's just a new priest. And he's at St. Catherine's, where Father Lease got sent to. So Father Lease is kind of like the priest in charge, and this other priest who's probably about 26 or 27, like works under Father Lease. So my friend's son, the priest, was doing like this video on Good Friday. Oh, I'm so lonely, like there's nobody to talk to. And it had to do with how Jesus felt alone on Good Friday, probably, like, you know, when his friends had kind of left him and all. But so this Father Josh is walking around, and he goes through the church, and he's like, I can't, there's no one in the church. There's no one here. He goes by Father Lease's office, and Father Lease is in there. Oh, hi, Father Lease. And Father Lease goes, oh, hello, Father Josh. I was just about to do some reading. And he had like a giant organic chemistry book. I was going to read organic chemistry, and there was some other big book of something that Father Lease would read. And Father Josh was like, oh, yeah, like I said, nobody to talk to. He kept going. But I thought it was so funny because it really reminded me of Father Lease, who would be reading organic chemistry for fun. And this chapter reminds me because the very first part says the word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. Okay. Study of trigonometry involves triangle measurements. A trigonometric ratio is a ratio of the length of two sides of a right triangle. One trigonometric ratio of triangle ABC is AC over AB. So when we're making a ratio of two sides of a right triangle, those are called trigonometric ratios. All right, at the bottom, you can see highlighted sine, cosine, tangent, and opposite over hypotenuse for sine, and cosine adjacent over hypotenuse, tangent, opposite over adjacent. See example 1, I found a video that is going to walk you guys through this example. I'm going to share my screen. I'll start it with you. We won't be able to finish, but you'll be able to finish without me. All right, I'm just going to show you. I put it in your Google Classroom. All right, I'm going to share my screen. You guys see my screen? You can probably see Brian real big. And you guys are along the side.
Yeah.
Okay. All right. Can you see This.
Yeah.
All right. See, it says example 1. I forwarded it a little bit. Example 1, express each ratio as a fraction and as a decimal. This goes along with example 1 on page 597. See, that's the same triangle? All right, I'm going to hit it. Hopefully.
Side is 15, and the hypotenuse is 17. So 15 divided by 17 is approximately 0.88. Cosine to P, remember cosine is adjacent to hypotenuse. So we have 8 to 17. Divide those, you get approximately 0.47. That's the cosine of angle P. And then the tangent is opposite to adjacent, so 15 over 8. Divide those out, and you get approximately 1.88. All right, now we want to do the same thing for angle Q. Sine is opposite to hypotenuse, so 8 divided by 17, that's 0.47. Then cosine for angle Q, adjacent to hypotenuse, that's 15 to 17. Divide 15 by 17, you get 0.88. And then the tangent to angle Q, we have opposite to adjacent. So we have 8 over 15, and that is about 0.53. Okay, using a special right angle to express the tangent of 30. So the tangent of this angle 30. Now remember, tangent is opposite to adjacent. So opposite to adjacent, so we're going to take x over x times radical 3. We can cancel out the x, and we have 1 over radical 3. Remember, no radicals in the denominator, so we're going to get rid of those, and we get radical 3 over 3, or approximately 0.58. So the tangent of angle 30 is 0.58. Now, the inverse trigonometric ratios, we can use this if I know that the tangent...
He stopped.
Okay. Let me get back to you guys. There you are. Okay. So that kind of walked you through example 1 there. I want us to try the guided practice. It says find sine of j, cosine of j, tangent of j. Okay. Who wants to go first? You can't all go at once. Grace, I see you raising your hand. Okay. I can't see everybody. So if someone else raised their hand, I'm sorry. Okay. Grace, sine of j. So sine, opposite over hypotenuse. Okay. What's the sine of j? I'm sorry, I didn't hear you.
5 over 13.
Good. Yep. How about cosine of j?
Give me a second.
So cosine is adjacent over hypotenuse.
13 over 5?
Well, 13 is your hypotenuse. Okay. So what leg is adjacent to j?
5.
That's opposite.
Okay, it's 12.
12 over 13.
Okay.
And one more for you, Grace. Tangent of j. So opposite over adjacent. So no hypotenuse this time. Opposite over adjacent.
5 over 12.
That's it. Good. Okay, Aristotle, could you do the k's for me? Sine k.
So, okay. 12 over 13.
Yes, good. Cosine k.
Cosine. Opposite. So 12. 12 over 5.
Cosine is adjacent over hypotenuse.
Oh, 5 over 13.
Yeah, 5 over 13. And then tangent k. So opposite over adjacent.
12 over 5.
That's it. Okay. Example 2, we're not going to have time to go into that today, I don't think, but I want you to read over that. We could use special right triangles, all right, to express tangents. So they'll do an example there. For example 2, I did put the video, and I have some problems I want you to work on. But if you have questions, I want you to come see me, like during office hours, watch the video, send me an email. Okay, and we'll go over it tomorrow. But let's do page 601. Let's try some of these just to get started. Let's do 1 through 7. All right, and let's do the bottom 16 to 21. 1 through 7 and 16 to 21.
Wait, which page?
Page 601. I'm going to write it down. Page 601, do 1 to 7, 16 to 21. Can you guys see that?
Mm-hmm.
Okay. All right. It's fun stuff, right?
Yeah.
Not sure I get it.
I get this. This is one of the few things I've been getting.
Okay. So I'm so sad that I can't hang up my SOH-CAH-TOA bulletin board for you. But that's just everything you have to remember. SOH-CAH-TOA. Okay. All right. You guys have a good day. Mrs. Warner just sent me a text message that you guys are supposed to tell Mr. Gilger happy birthday today, maybe.
Yeah.
Yeah, and so she said we're going to his office hour at 2. So
Yeah.
I guess he's not jumping into hers, so you're going to have to jump into his.
Okay.
Okay, so 2 o'clock, maybe jump into Mr. Gilger's at 2. Okay. All right, you guys have a good day.
Thanks. You
Okay,
too.
bye.
All right. See ya.
Bye-bye.
you.